The heat wave gripping so much of the world right now is already dying. But what is quietly building behind it in the depths of the Pacific Ocean is the reason climate scientists are watching their screens a little more nervously than usual. Some of the tracking maps used to chronicle global temperature records are already running out of colors to show what comes next. Stick with me for the next few minutes, because this is one of those stories where the headline everyone is talking about, the current heat, is actually the smaller half of the story. The real story is what happens after it fades, and why so many scientists expect the next couple of years to be even hotter, not cooler, once this current pattern finally breaks. This is not speculation pulled from a single alarming source either. It is the consistent conclusion being drawn right now by several major national and international forecasting centers, all independently tracking the same shift unfolding beneath the surface of the Pacific Ocean. To understand what is happening, you need to understand a cycle that quietly runs the entire planet's weather, whether you have ever heard of it or not. It is called the El Niño, Southern Oscillation, usually just shortened to ENSO, and it describes a natural recurring shift in ocean temperatures across a massive stretch of the tropical Pacific. This cycle has two opposite phases. La Niña, the cooler phase, happens when sea surface temperatures across the central and eastern Pacific run below average. El Niño, the warmer phase, is the exact opposite, when those same waters heat up well beyond normal. Neither phase lasts forever. The ocean swings back and forth between them every few years, and every time it does, weather patterns shift dramatically across nearly every continent on Earth. The mechanism behind this shift comes down to wind and water working together in a feedback loop. Under normal conditions, trade winds blow steadily from east to west across the tropical Pacific, pushing warm surface water toward Asia and allowing cooler water to rise up from the depths near South America. During La Niña, those trade winds strengthen, intensifying that natural pattern and pushing sea surface temperatures even lower than usual in the eastern Pacific. During El Niño, the opposite happens. The trade winds weaken, sometimes even reversing direction temporarily, which allows warm water that would normally stay pinned near Asia to slosh back eastward across the Pacific, essentially exposing a much larger stretch of ocean surface to unusually warm water. Because oceans store heat far more efficiently than the atmosphere does, this shift in surface water temperature has an outsized ripple effect on weather patterns across the entire globe, not just the immediate region around the Pacific itself, since the atmosphere above that warmed ocean effectively becomes a new engine, driving pressure systems and jet stream patterns thousands of miles away. For the past couple of years, the planet has been sitting in a weak La Niña pattern, and if that sounds like it should have made things cooler, that is exactly the point that is about to get complicated. Even during a La Niña phase, this year still produced brutal record-breaking heat waves across Europe, brutal heat domes across the United States, and dangerous extended heat alerts covering, well, over half the American population at different points in recent months. That already tells you something important. The baseline global temperature has climbed so much that even the supposedly cooler half of this natural ocean cycle is still producing historic, dangerous heat events almost every single year now. Here is where the real story begins. According to the latest forecasts from NOAA's Climate Prediction Center and international climate modeling groups, La Niña is now rapidly collapsing. Multiple independent forecasting models using both surface ocean data and subsurface temperature readings deep below the Pacific are all pointing toward the same outcome. The cool phase is breaking down fast, and in its place, a new El Niño event is forming, one that multiple forecasting centers now expect to strengthen into a strong, possibly even a super El Niño by the time it peaks during the coming winter. This matters more than most people realize because of one simple, well-documented historical pattern. Some of the hottest years ever recorded on planet Earth did not happen during La Niña years. They happened during, or in the year immediately following, a strong El Niño event. Look back at the historical record and the pattern becomes hard to ignore. The extremely strong El Niño event of 2015 and 2016 helped push 2016 into the record books as one of the hottest years ever measured at the time, a record that stood for years afterward. More recently, a strong El Niño developed through 2023, and 2023 went on to break the global temperature record outright, only for that record to be broken again the very next year in 2024, as the lingering warmth from that same El Niño event continued working its way through the climate system, even as the ocean cycle itself began shifting back toward cooler conditions. This is not a coincidence that happened once or twice. It is a pattern researchers have documented across multiple El Niño cycles going back decades, consistent enough that climate scientists now treat an incoming strong El Niño as a fairly reliable early warning sign that global temperature records are likely to fall within the following 12 to 18 months. The extra ocean heat released into the atmosphere during El Niño tends to push global average temperatures noticeably higher on top of whatever long-term warming trend is already happening. from greenhouse gas emissions. In other words, the natural cycle and the long-term climate trend can sometimes stack directly on top of each other, and when they do, the results tend to break records. While we are on the subject of records being broken, if you are the kind of person who wants to actually understand what is coming instead of just reacting to another scary headline, go ahead and hit that like button. And subscribe if you have not already, because understanding this cycle is going to matter a lot over the next year and a half. Now let's talk about those maps, because this is where the story gets visually strange in a way that is hard to unsee once you notice it. Weather and climate agencies around the world use color-coded temperature maps to communicate forecasts and records to the public, running from cool blues on one end of the scale up through yellows, oranges, and deep reds to represent extreme heat. For most of modern history, that scale was more than enough. Red at the top end of the chart represented the worst-case scenario, temperatures so extreme they were considered almost unthinkable. That stopped being enough a while ago. Back in 2013, Australia's National Weather Bureau had to literally redesign its own forecasting charts, adding brand new colors, deep purple and pink, specifically because the country's temperatures were pushing past 50 degrees Celsius, a threshold the original color scale was never built to display. It was not a symbolic gesture. It was a practical necessity because the existing chart simply could not visually represent numbers that high. Climate researchers at the time openly debated whether the actual temperatures would reach those new extremes, but the fact that meteorologists felt forced to redesign their own instruments just to keep up with reality should tell you something on its own. That same pattern is now repeating itself worldwide, just with different specific numbers each time. In recent summers, meteorologists covering historic heat waves across Europe and the United States have had to introduce darker and darker shading at the top end of their temperature maps because the traditional bright red used to represent extreme danger was no longer sufficient to visually separate a bad heat wave from a genuinely unprecedented one. Some forecasting systems have effectively started running out of usable colors, forcing cartographers and meteorologists to reach for darker maroons, deep purples, and, in some visualizations, shades approaching black, specifically to represent temperatures so far outside historical norms that the original map simply was not designed with them in mind. When a graphic designed to represent the worst possible heat starts needing brand new colors just to keep functioning, that is not dramatic exaggeration. That is a direct physical sign that the range of what counts as normal has shifted. There's a practical reason this keeps happening, rather than agencies simply building bigger scales from the start. Weather and climate mapping systems are typically designed using historical data, meaning the color range is calibrated based on the most extreme temperatures ever recorded in a given region at the time the map was built. For decades, that approach worked perfectly well, because genuinely record-shattering heat was rare enough that existing scales rarely needed adjustment. What has changed is the frequency. Instead of a once-in-a-generation event occasionally pushing past the top of the scale, meteorologists are now seeing temperatures brush up against or blow past those upper limits repeatedly, sometimes within the same summer, which forces agencies to treat scale redesigns as an ongoing maintenance task rather than a rare one-time fix. Some meteorologists have started describing this as chasing a moving target, redesigning charts, only to find, a year or two later, that the new extreme colors are already being tested again by the next record-breaking event. Here's why the incoming El Niño specifically raises the stakes on this pattern even further. During El Niño years, the tropical Pacific releases an enormous amount of stored ocean heat directly into the atmosphere, heat that had been building up beneath the surface during the preceding La Niña and neutral phases. Multiple independent long-range forecasting models covering the transition into this event are already showing strong, consistent agreement, which climate scientists consider a high-confidence signal rather than a shaky, speculative one. This kind of model agreement matters a great deal in seasonal forecasting, since any single forecasting model can occasionally produce an outlier result based on its own particular assumptions and limitations. But when institutions using entirely different data, sources, different computing approaches, and different research teams all independently converge on the same basic outcome, forecasters treat that convergence as a much stronger signal than any one model could provide on its own. Forecasters tracking the current transition describe this as a rapid collapse of La Niña, with clear indications of a full El Niño state forming by fall of this year, and continuing to strengthen through the coming winter, potentially even persisting into a second year afterward. If that pattern plays out the way current models suggest, the practical, everyday impact is straightforward, even if the underlying ocean physics are complicated. Regions already struggling with dangerous heat this year could see conditions intensify rather than ease once El Niño fully takes hold, particularly heading into next summer. Certain areas typically see a shift in exactly where the worst heat and drought concentrate. Since El Nino and La Nina do not just change how hot the planet gets on average, they also reshuffle which specific regions bear the worst of it. Some areas that have struggled with unusual cold or excess rainfall during this La Nina phase could flip toward drought and heat, while other regions might see the opposite shift. To make that reshuffling a little more concrete, El Nino tends to follow certain broad regional tendencies that meteorologists have documented across many past cycles, even though the exact strength and timing always varies somewhat from one event to the next. Parts of the southern United States, which often experience drier conditions during La Nina, frequently see wetter patterns return once El Nino develops, while the Pacific Northwest and northern tier of states, which tend to see wetter La Nina winters, often swing toward warmer and drier conditions instead. Across the Pacific, El Nino years have historically been associated with reduced Atlantic hurricane activity, since the stronger upper-level winds that come with El Nino tend to disrupt storm formation, even as they simultaneously raise the odds of drought and wildfire risk in parts of Australia, Indonesia, and southern Asia. Regions that depend heavily on rainfall patterns, El Nino tends to suppress. None of these regional tendencies are guaranteed to play out identically every single time, since every El Nino event has its own quirks, depending on exactly how strong it becomes and how it interacts with other shorter-term weather patterns. But the broad direction of these shifts is consistent enough that seasonal forecasters build their outlooks around them every time a new event begins to form. There is an important distinction worth making here, because it separates a solid, evidence-based explanation from pure fear-mongering. ENSO cycles are completely natural. They have been swinging back and forth between El Nino and La Nina for as long as scientists have been able to measure ocean temperatures, long before industrial greenhouse gas emissions became a factor at all. Nobody is claiming El Nino itself is caused by climate change. What climate scientists are pointing to instead is the way this entirely natural cycle now operates on top of a planet that is already roughly 1.25 degrees Celsius, warmer on average than it was before industrialization. A useful way to picture this is to imagine a swing set installed on a floor that keeps slowly tilting upward year after year. The swing itself still moves back and forth exactly the way it always has, following the exact same natural rhythm. But because the floor underneath it keeps rising, every single arc of that swing now reaches a little higher than the arc before it, even the ones that are technically on the cooler, low R end of the natural cycle. The natural swing is the same as it has always been. The baseline it is swinging on top of has shifted upward, and that shift is what keeps pushing supposedly ordinary El Nino years into genuinely record-breaking territory. This is also exactly why scientists pay such close attention to the specific years when El Nino and long-term warming happen to align. Several of the hottest years ever directly measured on Earth occurred either during a strong El Nino or in the months immediately following one, when the extra ocean heat released into the atmosphere was still working its way through the climate system. If current forecasts hold and this incoming event does strengthen into a strong or super El Nino by winter, meteorologists widely expect the following year to have a very real shot at setting new global temperature records, not because anything unprecedented is happening to the physics of the planet overnight, but because two well-understood forces, natural ocean cycling and background warming, are lining up to reinforce each other at the same time. None of this means every single day for the next year will be unbearably hot everywhere at once. Weather remains messy, regional, and full of short-term variability no single ocean pattern can fully control. Some regions could genuinely see relief from certain conditions, particularly places that benefit from the specific rainfall and temperature patterns El Nino tends to bring. But on the scale that actually matters for tracking global climate records, meaning the yearly average across the entire planet rather than any single storm or single city's forecast, the transition, currently underway in the Pacific, is one of the more significant, well-forecasted shifts scientists have flagged in years, precisely because so many independent models are agreeing on the same outcome using different methods and different data sources. It is worth remembering that global averages, records, and local day-to-day weather are two very different things measured on two very different timescales, and a strong El Nino influencing the former says very little about what any single afternoon will actually feel like outside your own front door. So here is the honest, complete picture, without the exaggeration and without downplaying it either. The heat wave dominating headlines right now really is likely to ease as the current weather pattern breaks down, exactly the way any individual heat wave eventually does. But underneath that short-term relief, a much larger, slower-moving shift is already underway in the Pacific Ocean, one that multiple respected forecasting centers now expect to bring a strong El Nino event by winter, and quite possibly the hottest global temperatures the planet has directly measured in modern record-keeping. The maps used to track and communicate these temperatures keep needing new colors for a very simple, unglamorous reason. The old colors were for a version of this planet that no longer fully exists, and cartographers are now stuck playing constant catch-up with a climate system that keeps testing the upper edge of what its own charts were ever designed to show. That, more than any single number or any single map, is probably the detail worth sitting with. It is not one dramatic, sudden event, pushing these charts past their limits. It is a slow, steady, well-documented climb, one El Nino and one La Nina at a time, each cycle landing on a slightly higher baseline than the one before it, until the tools built to track it simply cannot keep up anymore without being redesigned. Whatever color eventually gets added next to represent the following record, the underlying story behind it will still be the same one this video just walked through. A natural ocean rhythm running on top of a floor that keeps quietly rising. If breaking down what is actually happening behind the scenes of these viral weather headlines is the kind of content you want. More of, make sure you like this video and subscribe to the channel, because this transition is only just getting started, and we will be tracking every update as the new El Nino takes shape over the coming months.